Hello, third hour. Sorry I couldn't be there with you today, but I'm going to do my best to walk you through the examples we would have done together in class today. So I'm on this page in your notes packet. It should be right after the page that we completed yesterday on rational exponents. And luckily, really, today's stuff is not all that different from what you were doing yesterday. I'm sort of just adding one more step to it. So we are just going to go through these 3 slides of examples today. So before we start, let's think about what we did yesterday. Yesterday we started talking about rational exponents, where we would take a fraction that had 1 as a numerator and we would split a number into that many terms. So just as a quick review, if I gave you 27 to the power of 1/3, we would take that 27, we would do a factor tree. So let's see, 27 is 9 and 3, and then the 9 is 3 and 3. So 27 to the 1/3 power is just equal to 3, because when I split 27 into all of its factors, I end up with 3 3s. So 27 split into 3 equal factors is just equal to 3. Okay, that's what we did yesterday. Now notice that all of your fractions yesterday had 1 in the numerator. Today we're going to start talking about fractions that don't have 1 in the numerator, and I think somebody in class actually asked about that yesterday, or maybe it was you asked about negatives. I don't remember. So today, instead of having fractions that look like 1/3, we are going to have fractions that look like 2/3. Now here's the good news. 2/3 is really just 1/3 in disguise. You can think of 2/3 as 1/3 times what? Do you know? 1/3 times 2 would give you 2/3. Okay? And if you're not sure about that, remember that when you multiply fractions, you can write that as 2 over 1. So if I multiplied straight across, 1 times 2 is 2, and 3 times 1 is 3. So I can take this 2/3 and split it. I can write it as a fraction that I already know how to work with and just say that I'm multiplying by 2. Okay, now don't get ahead of yourself. Don't go thinking that we're going to just multiply these by 2. That's not quite how it works. But I want you to think back to this process. You already know how to work with this. And remember, we always look for things that we already know how to do. And now I'm just adding this extra piece in there that's going to complicate things just a little bit. So back to your notes, and I'm actually going to zoom in on this top right, this first example that says all fractions can be split. And I want you to look at that example, 25 to the power of 3/2. Well, remember that 3/2, I could separate that into a fraction I already know how to work with and a 3. So I'm going to start by writing that as 25 to the power of 1/2. And then, because I really want to end up multiplying this 1/2 by 3, but remember that with exponents, to do that, you raise a power to a power, and that's how you multiply. I'm going to take that 25 to the 1/2 power and multiply by 3. So it's like I'm taking it apart. Okay? And when I take it apart, now I have something that I know how to work with. I know how to do 25 to the 1/2 power. And then the way I've written this just means that I would have to raise that to the power of 3 when I'm done. So let's think about 25 to the 1/2. Remember, that means that I'm taking 25 and I'm splitting it into 2 equal factors. Not dividing by 2. Think of 2 things that multiply to make 25. This one you could probably do without even doing a factor tree. But if I take 25 and split into 2 equal factors, I get 5. So 25 to the 1/2 power is just equal to 5. Now I've still got this 3 floating out here. So what I'm going to do is just stick it over here on the 5. I need to do 5 to the power of 3 now. And that, if you need to type that into a calculator, you can. But 5 to the power of 3 is just 125. So again, your process is almost exactly the same. You're still splitting it into this many pieces, and you can just look at this original fraction, look at the denominator and say, that's the number of pieces I'm splitting into. Just at the end, when you get that answer, now you've got to go back and raise it to this power of 3. Okay? I suggest when you're starting out today that you do write all of your problems like this before you start. Eventually you'll probably get to the point where you don't need to do that, where you can just look at the denominator and say that's how many pieces I need, and then look at the numerator and say that's the power that I need to raise it to when I'm done. Okay? Let's try some more. Okay, here's your next set of examples, and I sort of split screened it so that I would have some space over here to do some factor trees, and then I can do my other work over here. Okay, you can lay this out on your paper however you want. I do know on the back of your page you've got a lot of blank space, so if you wanted to use some of that space to do your factor trees, you could if you didn't want this to get too crowded. So the first thing I would think when I look at that 64 to the power of 5 6 is I would say to myself, that's really the same thing as 64 to the 1/6 and then raised to the power of 5. Okay? So my first order of business, just like I was doing yesterday, is I need to take 64 and split it into 6 equal factors. So I would start my factor tree for 64. Probably most of you went 2 and 32. Certainly other ways you could go about it. 32 could then be 2 and 16. 16 is 2 and 8. 8 is 2 and 4. And then 4 is 2 and 2. So my factors I ended up with was 1, 2, 3, 4, 5, 6 2's. So splitting 64 into 6 equal factors, each factor is equal to 2. Okay? And then I'm going to raise to the power of 5 still. So 2 to the power of 5 is equal to 32 for my final answer. Okay? So that's what this is telling you, is split into this many pieces, okay, and then raise to this power when you're done. Okay, there's your first example. I'll give you a minute to copy that down if you still need it. All right, let's try the next one. Okay, so for the next one, negative 1024 to the power of 4/5. Again, this number is what's telling me how many pieces I need to split into. So let's check this because this is negative. Remember, the negative ones you have to be careful with. So if this is a negative number and I'm splitting into an odd number of pieces, that does work. We run into problems when we're splitting negatives into even numbers of pieces, but odd numbers on the bottom are okay. Okay, remember the bottom number tells you the number of pieces you're splitting into, so that's the one you care about. The top number doesn't matter, okay, as far as it being negative or not. So let's rewrite this for ourselves. What this really means to do is negative 1024 to the power of 1/5, and then raise that to the power of 4. Okay? And remember, to deal with something like this, I would just work with the 1024. Don't worry about the negative. We'll tack that on in a minute. Okay, so let's make a factor tree for 1024, because that sounds like fun. Okay, so 1024, doing this off the top of my head, so I really hope I don't make a mistake, is 2 and 512. Then for 512, you get 2 and 256. Then 2 and 128. 2 and 64. 2 and 32. 2 and 16. To save myself some space, I'm going to go 4 and 4. And 2 and 2. 2 and 2. Okay, that's a lot of 2's. How many did I end up with? 5, 6, 7, 8, 9, 10. I have 10 2's altogether. And remember that this power of 1/5 means I need to put them into 5 groups. Okay? So you have 10 2's and you need to put them in 5 groups. How many 2's does that mean are going to go in each group? Think about it for a minute. You have 10 people in a classroom and you need to put them in 5 groups. How many people are going in each group? Hopefully you're coming up with 2. So I'm going to put 2 together, 2 together, 2 together, 2 together, 2 together. And that gives me my 5 groups. 1, 2, 3, 4, 5. Which means that each group is actually equal to 4. Okay? So negative 1024 to the 1/5 power is actually equal to 4. And, well, I said that wrong. Technically, 1024 to the 1/5 power is 4. And then I've got to take this negative sign and tack it on. So this is really a negative 4. Now I'm going to take that negative 4 and raise it to the power of 4. Okay? And in your calculators, of course, you're going to remember to put that in parentheses, right? So negative 4 to the power of 4, I believe it's, yep, should come out to be positive 256. And it should come out positive because if you're raising a negative number to an even power, it's going to come out positive. Okay? So all of this and this here, none of that is new. The only piece that's new is this little number on the outside. Don't let that freak you out. Okay? Let's try one more. Let's see if we can do this one. We might be able to do this without the factor trees. We'll see. Okay, so for this next one, remember we're going to deal with the top and the bottom of the fraction separately. So we're really going to do 64 to the 5/2 and 9 to the 5/2, which means you're going to do 64 to the 1/2 and then that to the power of 5. I'm just taking them apart just like I did up above. And then I'm going to do 9 to the 1/2 raised to the power of 5. Okay? So again, I'm just taking the numerator of the fraction down. Okay. 64 to the 1/2 is really saying take 64 and split it into 2 equal factors. We talked about this yesterday. Taking the power of 1/2 is really the same thing as finding the, I really hope you just said square root. 64 to the 1/2 power, you're looking for 2 equal factors that would multiply to make 64, which should be 8. Okay? And then that still needs to be raised to the power of 5. 9 to the 1/2 power is going to be 3 because you're splitting 9 into 2 equal factors. Think what times what gives you 9. So that comes out to be 3. And we still need to raise that to the 5th power. Okay? So let's see, because I don't know these off the top of my head. 8 to the power of 5 is going to be 32,768. 3 to the power of 5 is going to be 243. Now, should we check this to see if it can reduce? Probably. But let me give you a hint. This fraction here at the end came from this fraction. Okay, 64 over 9. It also came from this fraction, 8 over 3. None of those smaller fractions can be reduced. And they're just powers of the same number. So if these smaller fractions can't be reduced, this one's not going to be able to be reduced either. If you don't believe me, go ahead and type it in your calculator and try to simplify it, but I think you'll find that it's exactly the same, that it just stays as 32,768 over 243. Remember, I prefer your answers as fractions as opposed to decimals. Okay? Give yourself a second to digest that a little bit. Okay, one more thing you're going to see today that we didn't work with very much yesterday is the return of the variables, okay? Return of the mystery exponents. Remember that all of your properties of exponents still apply. And by properties of exponents, I mean all of those things that we wrote in our flip book. Like what happens when you do a power to a power or multiply 2 powers, things like that. All of those properties still apply, okay? So here, I've got x to the 2/3, y to the 1/2, both being raised to the power of 2/5. Okay? You're raising a power to a power. Your rule for that is that you multiply. So for the x, I'm going to take x and then multiply 2/3 times 2/5. And remember, for fractions, we're just going to multiply straight across. So that's going to be 2 times 2 is 4, 3 times 5 is 15. So this would become x to the 4/15. For my y, I have y to the 1/2. I'm going to multiply that by the 2/5. Again, you're raising a power to a power. 1 times 2 is 2, 2 times 5 is 10, so that gives you y to the 2/10. Now 2 over 10 does reduce. Okay, 2/10 reduces to 1/5, so that's really y to the power of 1/5. So as a final answer here, let's see, I'll put my final answer down below. I'm going to put my x and y back together. Now I can't combine them because they're not like bases, but I would write x to the power of 4/15 and y to the power of 1/5. And that right there is just what it wants you to do. Just simplify. Okay? This is the same thing as if, let me give you an example of this to give you some context here. If I had given you a problem that said, you don't have to write this down, but x squared y to the 3rd to the power of 5. Wouldn't you just take these exponents and multiply them by that 5? This 5 gets applied to both of those exponents. It's the exact same process. You're just working with fractions now instead of regular numbers. Oops, that didn't erase like I wanted it to. Okay, so on to this next example. Now this one is a little bit trickier because remember that when you have this number in front, it's just a regular number. It's a coefficient. So that means we can't just multiply 16 times 3/4. We want to raise 16 to the power of 3/4. So let me work through that kind of separately here, just as a review of what we just did. So 16 to the 3/4, you're really going to think 16 to the 1/4, and then raise that to the power of 3. Well, to do 16 to the 1/4, you'll need a factor tree. 16 is 4 and 4, and then 2 and 2. Okay, so if I split 16 into 4 equal factors, my 4 equal factors are all 2's. Okay, so this would now become 2 to the 3rd power, and 2 to the 3rd power is equal to 8. Okay, so 16 to the power of 3/4 gives you 8. Then I'm going to work with this a. Now this a is, the 4 is an exponent. Okay, so this is a power raised to a power. Your rule for that, remember, is different. Your rule for that is that you multiply. So you're going to take a to the 4th, and those powers are going to be multiplied, so it would be 4 times 3/4. I would hope that you could look at that and come up with the answer off the top of your head, but in case you can't, remember that 4 is really like 4/1. Sorry, that's hard to read, but it says 4/1. If you multiply that straight across, you would end up with a to the 12/4, and 12/4 reduces to 3. So that's really just a cubed. Let's put these two things together for my final answer would be 8a cubed. Okay. So if you've got regular numbers in there, you may have to go through this process. Okay. Otherwise, your rules for your exponents, all of those things that we talked about that we wrote down in that little organizer, all of those still apply. Okay. Let's give this a shot today. The back side of this notes page talks about negatives, and we will get to those tomorrow. Really, I just wanted to introduce you today to the concept of having numerators in your fractions other than 1. Okay, so give that a shot. Homework for tonight is Lesson Master 7-7, and I will put sort of some helpful hints for that up online too, to kind of get you started on the different sections of your homework. Okay, so I do expect 7-7 to be done when you walk into class tomorrow. I will be around after school today if you need me for anything. Okay, have a great day.